Welcome to another video lab of MrLopezClasses.com. In this lab, we are going to check the inverters, the marine inverters. And we are going to analyze the procedure to calculate the inverter appropriated and the procedure to install the inverter appropriated. You can do that lab with your instructor or by yourself if you have access to a boat with a good marine inverter. And we are going to check some tips and recommendations for that installation. Remember that the inverter is one of the three sources of AC power in a typical boat. The other two sources are the pedestal, the shore power, and the other one is the generator. I explained in my video related with the inverters that the power produced for the inverters is not perfect, it's not real. For that reason, there's no frequency. The frequency is produced in a circuit board. For that reason, the power produced for the inverters is used for some equipments in the AC panel. In the majority of the boats, they have a mark with a special label indicating that if the boat is working with the inverter, those elements should be connected with inverter. The other ones no, because probably they need real current, real power. Okay, we are going to analyze in this particular example. I have a picture that I prepared, that picture, and in that picture I connect an inverter. This is the DC side. This is the DC side, and this is the negative and the positive, and the group of batteries, and this is the main breakers to activate the inverter. Check with your instructor in the marine inverter that they have in the lab or in the boat. Where is the main breaker, the DC main breaker at the input of the inverter? This is the element, the breaker used to activate the inverter. And check in the output of the inverter that there are one group of terminals for output voltage AC and other one for input. And now we are going to analyze what is the meaning of that. Those are for output and those are for input. Okay, the output is the AC output that the inverter produces when the inverter is working. Normally the inverter have an on-off switch on top of the inverter or on the side of the inverter. This is to start to produce AC current. When that switch is off, it's not producing current, some current is entering from the AC panel in order to activate the battery charger located internally in the inverter to keep those batteries properly charged, to keep the batteries of the inverter properly charged, fully charged. Yes, inside of the marine inverters, you have a battery charger, and that battery charger is used when the inverter is not producing power to keep this battery bank properly charged. Okay, now we are going to talk about that. Okay, we are going to check the DC side, and in the other side, in the AC side, we are going to analyze in your lab with your instructor or by yourself in a boat, how is the wiring? How many breakers are connected in the output? Why this breaker and this breaker is not connected when you select here in the AC switch selector inverter? When you select inverter, not all the breakers can be activated. They have labels to select the breakers appropriated. This is because there are equipments with high consumption, and they are not recommended to work with inverter. I explained that situation in my video, in the video of this class. Okay, my friends. Other important thing that I want that you analyze in the lab is the calculation of the battery bank and the connection of the batteries in the DC side of the inverter, how those batteries are connected, and the capacity of those batteries in amps per hour. Remember that the batteries, they have in the label the CCA. This is the cold cranking amps. That information is relevant, is important when you install those batteries with star motors, right, for cranking purposes. And also the battery, they have in the label other information related with the RC, or reserve capacity, and other information related with amps per hour in some batteries. The information that is important is the information related with amps per hour. Remember that amps per hour is equal to 0.467 times the reserve capacity. This is the formula used to convert. You remember that slide in our book of electricity, in this book? Yes, that the formula to convert reserve capacity into amps per hour. Okay. Alright, my friend. I want that you check the DC side in details. Analyze the group of batteries, where are located, where is located the switch to activate the power coming in into the inverter, how is the configuration of the batteries, what type of batteries are used in that configuration, deep cycle, cranking, how is the configuration of the bank, and how much is the total capacity of the bank according with that configuration. Remember, you did that project in the laboratory related with the connection of batteries in series and parallel. Remember that? Okay. We are going to do that procedure exactly the same. This is very, very important because we are going to check one example. Suppose that this battery charger is used to produce in the output 4 kilowatts. 4 kilowatts in two phases, 240 volts AC. In the output, that inverter produces 4 kilowatts, 4,000 watts, and 240 volts is a double phase. Okay? And we are going to check according with this output, the output of that inverter, how much should be the capacity of the battery bank, and how, depending on the batteries, how are connected those batteries. We are going to check right now, and I want that you check in your boat if that group of batteries is appropriated, if that group of batteries is properly connected, and if that group of batteries is with the capacity, with the enough capacity to produce the output power. In this particular example, we have an inverter of 4 kilowatts, 4,000 watts. You remember the formula for power? You remember that power is equal the voltage times the intensity. The power is 4,000 watts, no? And the voltage is 240. How much is the intensity? Intensity is power divided by voltage. Okay, this is in the AC side. If I want to produce 4,000 volts in the AC side, I need put in the input the same and a little more. Why a little more? Because you have a dissipation of power, because of heat, because friction, because a lot of factors affect the output. You need put in the input a little more, normally 10-20%. We are going to do the exercise because the power at the input in DC should be equal to the power at the output AC. But I am going to add it in the input 20% for safety factor. Safety factor, because dissipation. Okay, I want to produce 4,000 watts. And I have at the input, how much should be the power at the input if I connect the batteries in series? If I connect the batteries in a configuration for 24 volts DC. Okay, it's 24 volts times the intensity should be equal to 4000. In that case, the intensity, 24 volts times the intensity should be equal to the voltage, to the power plus 20% divided by 24 volts. The power, 4000 volts plus 20% is 4800 watts divided by 24. This is 200 amps per hour. This is the amount of amps that I require in 1 hour in the DC side in order to produce 4 kilowatts in the AC side. This is in theory, because remember that how much you can discharge the batteries? Yes, only 50%. For that reason, really, this is not for 1 hour. This is for 30 minutes. In order to avoid discharge the batteries more than 50%. Okay, Mr. Lopez, I have a lithium battery. Okay, you can discharge those batteries a little bit, 75%. I don't recommend complete. I recommend no more than 75 if there are special batteries like cadmium batteries, titanium batteries, lithium ion batteries. But it's a regular battery, lead acid, never discharge more than 50%. Okay? That's good? Okay, this is the situation. I need 200 hours in the configuration of my battery bank in order to keep my inverter running, producing 4,000 watts in 1 hour. I need 3 hours. Okay, you need multiply 200 times 3 and you need to put more batteries. Depends on the capacity of the batteries. Remember that there are batteries with higher capacity in amps per hour. You remember when I explained the golf cart batteries? Those golf cart batteries are designed in 6 volts, 8 volts, and 12 volts, and 24 volts also. The batteries with less voltage have higher capacity in amps per hour. I recommend batteries of 8 volts or 6 volts, and you configure it to produce 24 and the amount of amps, 200 amps. You connect in series, in parallel, or in series parallel. That's the secret. I want that you check in the lab with your instructor if that group of batteries is appropriate for that inverter. Okay? This is wonderful. This is nice. This is the procedure to install an inverter. And I want that you check in your boat, in the boat that you have in your marina, in your own boat, if the inverter is properly installed. If you have questions, you can write those questions to info@mrlopezclasses.com, and I will be happy to solve your questions. And I will be happy to help in your design. I will be happy to help in the selection of the inverter appropriate for your boat. And normally I recommend the inverter like a backup, not the constant power. However, there are some sailboats and catamarans that they have the inverter working all the time, and the AC power internally in the boat is coming from the inverter. This is a good design because in that particular case, the power, AC power, feed the air conditioning equipment and the stove, the refrigerator with AC power. And that AC power is coming from the inverter. And the inverter receives the power from the battery bank. group of batteries, and those group of batteries are fully charged all the time because the majority of those sailboats and catamarans, they have solar panels and they have a windmill. This is the perfect configuration, that configuration. This is very common in sailboats and catamarans. And yes, the power, the AC power in those designs is power coming from the inverter. I hope that you analyze with details, with critical thinking, the inverter, the AC side and the DC side. You remember that I explained at the beginning of this video lab that in the AC side, the majority of the marine inverters, they have one group of terminal for power coming in and other group of terminals for power coming out. The power coming out enter in the AC switch selector, and after that enter in the main breaker, and from the main breaker you have the small separated breakers. This is the power coming out from the inverter. But the inverter has power coming in. The power coming in is the power used to activate the battery charger in order to keep those batteries fully charged. This is in case that the inverter is not producing power. Okay, that power is coming from the main AC panel. One of the breakers, they have a label, and the label says inverter/charger. This is when the AC switch selector is selected in generator or short power. You can keep those batteries fully charged because the sun is low, the level of intensity in the sun is low, the solar panel is not producing good power, and the windmill is not producing power, and the inverter is not producing power. I am using the generator, or I am using the short power line. I can activate this breaker, and the batteries, the group of batteries, will be fully charged. Okay? I want that you analyze in your marina where are located those terminals for in power and where are located those terminals for output power. This is nice. This is the project related with inverters. I hope you enjoy this wonderful lab.